everyone, I am Dr. Jagadha, Associate Professor in the Department of Mathematics. We will discuss about the topic problems on triple integrals. We'll discuss in detail about definition of triple integrals, problems based on triple integrals. So the definition of triple integrals. So we can see it, the triple integral, that is f of x, y, z, dx, dy, dz. Triple. It is in 3 dimension. So we can see it here, 3 integrals are there. This, it is in Cartesian form. The problem which we are going to discuss about the Cartesian, to evaluate the integral that we are going to convert it into polar form. So which takes the position, that is x r sine theta cos pi, y r sine theta sin pi, and z r cos theta, and dx dy dz using Jacobian, that is r square sine theta dr d theta d pi. This is the formula for triple integrals. Now, the first problem, evaluate 0 to infinity, the interior one. The outer one is also 0 to infinity. The outermost, the middle one, 0 to infinity. Outermost one also 0 to infinity. So dx, dy, dz, which is divided by 1 plus x square plus y square plus z square, the whole square. This we have to do the integration. So now the solution, it is very difficult to integrate this integral in Cartesian form. So the polar form, if it is there, we will be very comfortable. So in that angle, so we are going to assume x equal to r sine theta cos pi, y equal to r sine theta sin pi, z equal to r cos theta. So the integral changes into spherical form. Now we can see it is a 3 dimension. The origin we named it as O, x-axis, y-axis, z-axis. Now here the point is 0, 0. Actually here 0, 0, one more 0 should be there. It is a 3 dimension. Now the values, the integral values in our question which is given, x 0 to infinity. 3 integrals which is given very clearly, 0 to infinity, 0 to infinity, 0 to infinity. That is x direction from 0 to infinity it goes on, and y direction, y dimension also from 0 to infinity it moves, and from here also it moves 0 to infinity. So all x, y, z, the 3 dimensions, they are in Cartesian form. According to our problem condition, from 0 to infinity it moves. We are in 3 dimension. So what I'm showing in the monitor, it is in 2 dimension. So now here it moves first. When we can see it here, why it is mentioned here. The y dimension 0 to infinity, it is shaded completely. So how long the y extends, even this area also extends. That's what the lines, the horizontal lines which represent. So we can see the next one. Here our z-axis, z limit of 0 to infinity. So how long this z up to infinity, even this complete, this is also, we will be extending. The vertical lines represents that. And same x direction, there is a 3D, third dimension. that is also extends even our area, that is also according to that the lines also we are extending. So now we can see it here. That is first what it is, that is completely y tends to infinity this direction. This is our z, it tends to infinity. It is another one side also, it tends to infinity. Put together three dimensions from origin to infinity we are moving. This step by step, this animation which explains that. Now we are going to calculate. So y direction 0 to infinity, z dimension also 0 to infinity, even x dimension also 0 to infinity. To calculate in Cartesian form that given integral, it's very difficult. So we will convert it into polar form. So we want it r radius, angles we want it. So r, very easy thing, a simple concept. If it y extends, z also extends, and x also we are extending, our lines also we will extending according to that. Then what about our radius? According to how long we are extending, y, z and x, r also will be the same. That's what r tends to infinity. We can see the figure which is in our first octet. So it's up to only the first octet. So the angle is pi by 2. We are in 3 dimension. The same only will be there, the third angle also, that one, pi is also pi by 2. In this here, the theta equal to 0, the starting, here we can see the line, the initial line. Here, the angle is 0, starting one. From here to here, that is 90 degree. That's what it is mentioned here. Now, the figure what we, the animations one step by step what we have done it, that's a figure which is kept here. Now, the solving the problem, we will move now. So, the limits of x, that is x from 0 to infinity, which is given in our question, and y from 0 to infinity, this condition also which is given in our question. What about z? Z is also from 0 to infinity. So all are in Cartesian forms. To make our job very easy manner, to make our integration, because a Cartesian form taking the evaluating integral, it is a very complicated one. For that reason, we selected the polar form. According to that, now x tends to infinity, y tends to infinity, z tends to infinity. Compulsory, our radius also tends to infinity in that angle which is written here. So the region of integration which is in the positive octant of the plane. Fine. Now the limits of r, because in the polar form, the 3 dimension, to do it, we require r, theta and pi. So from this, it's a basic concept. X, y, z, the dimensions are up to infinity. Then our radius also up to infinity. We have shown in the figure. So r from 0 to infinity, we can see it very clearly from origin to, that's what here this, we can see the animated this mark, that is we are going to evaluate. Here we can see it. One more dimension also is there, because what we are showing that, PPT which is in 2 dimension, but our problem which is in 3 dimension. So r from 0 to infinity. So this theta from 0 to pi by 2, that is angle we can see it. 0 to 90 degree. The next one, pi from 0 to pi by 2, that is our third dimension. The angle is same. So this is the figure which is kept here. So the spherical of the given integral is, this is our equation. Now we know it, our dx dy dz, that is replaced by our polar form, is nothing but r square sine theta dr d theta d pi, that is using the Jacobian that we obtained it here. Just now dx dy dz, which is Cartesian to polar form, and this one which is written as it is. This complete one, x square plus y square plus z square, which is equal to r square, that is given in our question, that is our problem. So r square. This square as it is. The first one, the angle we are taking 0 to pi by 2. Here also 0 to pi by 2. And r is 0 to infinity. So we can see it now, r square sine theta dr d theta d pi divided by 1 plus r square the whole square. So we, regarding r, that we grouped it. We can see it here, r square. Here the terms where I am putting, they are related to r. That is r square dr divided by 1 plus r square the whole square. The next integral is 0 to pi by 2. Regarding theta, the terms are what I am circling. That is sine theta d theta. So the third one is 0 to pi by 2 d pi. This integration, we have to do it. For that, this complete in terms of r, it is there, that we are going to substitution method. In terms of t, we are going to change. For that, r equal to, we are taking tan theta, and both the sides we are doing the differentiation. R differentiation is dr, tan theta, the differentiation is secant square t dt. When r equal to, here we can see it, when r equal to 0, here we are substituting. When r equal to 0, tan 0 we are putting. When r equal to 0, 0 equal to tan t. So t is nothing but 0. But here infinity it is there. So when r equal to infinity, at what point this our trigonometric function tan has a value infinity? At the point 90 degree, pi by 2. So this 0 is 0, whereas infinity, it is going to replace by pi by 2. So we can see it. This is how the second and third we didn't touch at all. This is the previous step. That is the previous slide. What is the last step? This 0 as it is, and infinity, it is replaced by pi by 2. Here r square is there. R we have taken as tan theta. So tan square t. Our dr, it's nothing but secant square t dt. That is also we can see it. Divided by 1 plus tan square. 1 plus tan square. It is a trigonometric identity, that is 1 plus tan square, it's nothing but secant square t. This is square, here square, same as it is. For this more simplifications we can do it. Here secant square, one power is 1, whereas down is 2 is there. So that simplified, we obtained tan square t by secant square t. Again, tan square, it's nothing but sine square by cos square, and secant square, it's nothing but 1 by cos square, but it is in the denominator. So up it is coming cos square. It both are getting cancelled. So here the simplified one we are getting sine square t. That's what which is written here. Now completely here sine square t, here sine theta, here d pi. So this sine square t, whenever the trigonometric ones, if they have power corresponding, the formula we have to substitute. In that concern, the sine square t, which is replaced by 1 minus cos 2t divided by 2 dt. The second and third integral just we have written as it is. This 1 by 2 we have taken outside. From 0 to pi by 2, 1 minus cos 2t dt, and second and third integral as it is just we have written. So we can see it now. 1 by 2, 1 by 2, and 1 into dt, that is t. This minus here minus cos 2t, the integral is sine 2t divided by the coefficient of t is 2. That's what here it is written. From 0 to pi by 2. The second integral is sine theta. The integral of sine theta is minus cos theta, 0 to pi by 2. The last one d pi, the integral is pi from 0 to pi by 2. So now the substitution 1, this 1 by 2 as it is. The t place we substituted pi by 2, this minus as it is. Here t we are substituting pi by 2. Already 2 is there. When we are substituting this getting cancelled. Sine pi, the value is 0. So the first integral completely we finished it. Next we will move to the second integral. For that upper limit is pi by 2. So minus cos 90, 0. Limit formula. And theta place lower limit value we are substituting 0. So cos 0, the value is minus 1 here which is written. The last one is pi. In the place of pi we are substituting the upper limit, that is pi by 2, minus the lower one is 0, just that we neglected it. So now here 1 by 2, this is pi by 2, minus minus it is 1, and here the pi by 2. So we can see it, this put together minus minus 1 into pi by 2, pi by 2. Here we can see it, this value is pi by 2, this value is 1, here pi by 2. So totally the final result we obtained for this problem, pi into pi, pi square by 8. So the next problem is evaluate, find the volume of the tetrahedron, that is triple integral x square yz dx dy dz over the region bounded by the planes, that is x equal to 0, y equal to 0, z equal to 0, and x plus y plus z equal to 1. The solution is, now this is the bounded region which is given in our question. that is x equal to 0, y equal to 0, z equal to 0 and x plus y plus z equal to 1, from which we will draw the geometrical figure, that is, it is in 3 dimension. So we can see it, this is the origin, we named it as O, x-axis, y-axis and z-axis. X, y, z in the question also, triple integral it is there, the symbol. So which the given problem falls under triple integral 3 dimension. Now we can see there is a point, that is a point P which lie on x-axis, and there is a point Q that is on y-axis, and there is a point on z-axis is our R. The coordinates are, this is when it lies the point P at 1, the point 1. Others are zeros. That is y and z. Here also, a point on y-axis, x and z are 0. Here there is a point on z-axis, x and y are 0. We are joining the points. And there is a vertical strip. The strip name is A and B. And overall, complete the 3 dimension which is given as an equation x plus y plus z equal to 1. Now, this is the figure which is just now what we have done, the animated one, the complete figure, the group as a group which is kept here. Now, we will solve this problem, for which we are taking a strip AB which is parallel to our z-axis, and AB starts from, we are noticing here, xy plane, yes, y is there, yes, xy plane, and terminates, we are in 3 dimension, the surface which is there in xy plane. Then, but complete figure, the complete figure put together, the 3 dimension, that which is in the form of equation which is given x plus y plus z equal to 1. So this vertical strip what we have taken, that it starts our xy plane, our xy plane, and terminates the touching this plane x plus y plus z equal to 1. Now, the limits of z from where to where? Here is our origin is there, 0, 0, 0. We are in 3 dimension. From 0 to this equation put together the 3 dimension, from which we can extract what is our z. So we extracted, then we obtained, that is 1 minus x minus y. Next one, so we are projecting the plane x plus y plus z equal to 1. And in the xy plane, if you are noticing, it is the surface which is a triangle one. The triangle one, the name is OPQ. Here is there. So now we wanted this PQ, the equation we want to obtain by putting z equal to 0, because from the figure itself, the picture is very clear. That is, this is y dimension, this is x. Z is 0 there, the figures Looking at that only easily we can see. So the total put together the three dimension, the common equation x plus y plus z equal to 1. There we are going to put z equal to 0. Then we obtained x plus y equal to 1. This is particularly the equation only for this surface of yx or xy plane, here which is written x plus y equal to 1. Now, this already just now we discussed, that is a vertical strip AB which is in the region xy plane, we told. The region name is in the triangle here, that is OPQ here which is written. That strip starts from our xy plane. The xy plane, the geometrical figure is triangle, because the total figure is tetrahedron. The each face of tetrahedron which is in triangle shape, that's what the triangle, the geometrical figure condition of it. So our vertical strip starts from our xy plane and terminates the three-dimension plane, the equation x plus y plus z equal to 1. Now, this is the figure, the grouped figure, from which now our surface, that is x plus y equal to 1, from which we can extract what is the limit of y. So the limit of y is nothing but from 0 to 1 minus x, from which easily we can x plus y equal to 1, y equal to 1 minus x, which is written here. Finally, this y also 0, then from x, this direction, from 0 to, from the coordinate itself we can tell, that is from 0 to 1 it moves. So now our limits, the triple integral from the z axis 0 to 1 minus x minus y for the z dimension, whereas y dimension from 0 to 1 minus x, x direction 0 to 1. So our volume integral, our triple integral, we can see it our z. So the interior integration z equal to from 0 to 1 minus x minus y of, this is our function which is given, that is x square y z dz dy dx. This is a volume integral dimensions, and strictly the interior one we defined for z, so we have to do the integration with respect to z only, it is compulsory. Next, our middle integration is from y. From y is taking the value from 0 to 1 minus x. The outermost integration is from 0 to 1. Now, we are going to focus on the integration, for which, so the interior integration z, here x square y is there, we are not going to consider it, other variables, but put together they are under the operation of multiplication, so we have to consider them as constants. So we rotate x square y as it is, treating them as constant. Z, the integration is Very simple integration. That is, we know it. Integral x power n dx. Simple integration. X power n plus 1 by n plus 1. Now our z power is 1. 1 plus 1 divided by 1 plus 1. So z square by 2. Our upper limit is 1 minus x minus y, and the lower limit is 0. So we focused our interior integration and we obtained, this is the result, what I circled 1. Now the leftover work is regarding our interior integration is the substitution is left over. So the substitution 1 is, this is the last step, what we obtained in the previous slide. Now we can say it, this where I am putting the tick, and here the tick, dy dy. We didn't make any changes here, these places. Whereas here the 2 is there, that we brought it outside 1 by 2. And this x square also we kept it before the integral. This y which is written as it is, and z place upper limit we are substituting. Our upper limit is 1 minus x minus y. Here we can see it. We substituted our upper limit, that is z the whole square. Limit formula sign. Lower limit is 0. So we can see it here. So we completely, even the substitution is over for the interior integration. So now, just where I am putting the ticks, we are doing the comparison with the previous steps. Here, wherever the ticks are there, there is no changes at all. Even y also it is written as it is. Only the thing is there, this part we neglected it, minus 0. So we no need to consider at all. Just we neglected, and this step. So the next one is, now we can see it very simple way. This we have to do. That is 1 by 2 integral 0 to 1 x square integral from 0 to 1 minus x y dy dx dx. No changes at all. Just from the previous step we have written. Where the changes we brought in, that is this place. Here this term we have taken as a, this minus is as it is, y we have taken as b, a minus b the whole square. Our a is 1 minus x, b is y. So we applied here completely our a minus b the whole square. We can see it, a square plus b square minus 2ab, treating a equal to 1 minus x and y we have taken as b. So a minus b the whole square formula, we used it and we have written here. So this is the last step. Now this simplifications we can see it. First, where we didn't bring any changes, we will do the comparison with the previous step. Where I am putting the tick here, there is no changes at all. Just we have written here dy dx dx. No changes at all. Now this y we have taken inside. So 1 minus x the whole square into y here, and y square into y cube This minus to 1 minus x as it is, but y into y square. Next, 1 by 2. Here integral 0 to 1 x square, and it should be here written. This dimension also should come, dx to be written. Here we have done it. Integration, that is a middle integration, we concentrated with respect to y. So when we are concentrating with respect to y, this 1 minus x square, which is written as it is, y integration is y square by 2, y cube integration is y power 4 by 4. This we didn't touch, as it is we have written. Y square integration is y cube by 3. For the y, with respect to y, the limits are, the lower limit is 0, upper limit is 1 minus x. This dx as it is. So we obtained here after the substitution, here dx should be there. So 1 by 2 integral over 0 to 1 x square of 1 minus x the whole power 4 divided by 2 plus, so we can see it here. Here is there. In this place we are substituting 1 minus x the whole square, put together 1 minus x the whole power 4. Here also 1 minus x the whole power 4. Here also we can see it, 1 minus x is there. Here 1 minus x cube is there. This is also 1 minus x the whole power 4 form we are getting. Here that's what we, every term 1 minus x the whole power 4 it is there. The first one divided by 2, second one divided by 4, the third one is divided by 3. Now put together we have taken LCM. So the LCM is 12. So 1 by 2 integral over 0 to 1 x square of. So to 12 we have taken the LCM. So the first one is divided by 2. So this is multiplied by 6. The second one is divided by 4. It is multiplied by 3. The third one is 3 divided by, so it is multiplied by 4. So 6 into 1 minus x the whole power 4. So the first term is 6 of 1 minus x the whole power 4. The second one is 3 of 1 minus x the whole power 4. Whereas here minus 2 and 4, minus 8 of 1 minus x the whole power 4 dx. Because of the last one which is pending, it should be written. Now this 12 we have brought it out. Put together it has become 1 by 24. So here 6 plus 3, 9 minus 8. So only 1, that is 1 minus x the whole power 4. Already x square is there. We have written as it is. Now this part we have to do the integration. That we will focus now. That is, here this 1 by 24 we have written here. This is very simple integration. X square into a minus b the whole power 4. That formula writing, expanding, and which is multiplied by x square. In that way also we can do it. Nothing wrong in it. Otherwise, this is a very simple way. This way also can be done. So we will see it, how the integration is done here. That is, this term, first we have written as it is. The second one, we did the integration. That is 1 minus x the whole power 4. Here, the simple integration, x power n dx, which is equal to x power n plus 1 by n plus 1. Our n is 4. So 4 plus 1 by 4 plus 1, 5. Then why we have written here minus 5? Why it is placed instead of 5 minus 5? Reason, x coefficient is minus 1 is there. That's what minus 5. Next, x square, the differentiation is 2x. Next, this we have to do the integration. Now, 1 minus x the whole power 5 integration we want. 1 minus x the whole power 5 integral we want. So 5 plus 1, 6. 6 by 6. But already minus 5 it is there. Minus 30. This minus put together, it has become 30. This part, we did the integration. Again, this part, we did the integration. Again, we are going to do the integration. Now, our n is 6. 6 plus 1, 7. Divided by 7. 7 into 30, 210. But x coefficient is minus is there. Minus 210. Why we stopped this procedure? We can continue, but we are not continuing. Because next again, 7 plus 1, but we stopped the procedure. The main reason is this, we have taken x square here. We did the differentiation. Again 2x differentiation 2. Again the 2 differentiation is 0. That is the reason we stopped the procedure. This part, integrated 1, we wrote it. Again integration. The middle signs, alternative signs are dominating. That is plus, here minus, here plus. Alternative signs will dominate. Now, the integration part we completed. The leftover, we have to apply the limits. So 1 by 24. So the upper limit is 1. Easy way, we can see it. Here 1, here 1, here 1. Completely. The upper limit, the value, if we substitute in the place of x, the value 1, completely upper limit, result is vanished. 1 minus 1. We got it 0. So, completely upper limit is vanished. The result is 0. Now, the lower limit, the value is 0. We have to substitute in the place of x. So, in the place of x to substitute, this is the limit formula. X place we are going to substitute. Here, x, this is becoming 0. After substitution of this lower limit, 0 into anything 0. Here also it is going to take the value 0. 0 into anything 0. Here this is taking the value 0. But 1 minus 0, 1. 1 power 7, 1. And 2 into, here we can see it. This position which is becoming the value is 1. Here we can see it. This 2 we can cut it. It is becoming 105. Minus 1 by 105 we are getting. Already 1 minus sign is there. This is regarding our limit formula sign. The final result is 1 by 24 into 1 by 105. So the final answer we obtained 1 by 2520. So we will come to a conclusion of this topic, problems on triple integrals. That is, first we have taken, that is the problem evaluate 0 to infinity, 0 to infinity, 0 to infinity. The triple integrals are there. So the given problem which is in 3 dimension. But looking at this function, if we do in Cartesian form, the integration will become more complicated. So that is the reason we converted this given problem into polar form. So to convert into polar form, we need radius, we need angles, we need pi, the value we needed. So simple concept, x, y, z, it tends to infinity. Our radius also tends to infinity. So we have drawn the figure looking at this condition what is given in our problem. So it is a 3 dimension. In this, the angle is 0. It is lies in the first octant. So here the angle is 90 degree. X, Y, Z, 3 dimensions, completely tends to infinity. How long they are extending? One more dimension is there. What I am writing, the slides, it is in 2 dimension. So one more dimension is there. That dimension is x. That is also tends to infinity. How long they are tending to infinity. How long the length it is increased. Same, the radius also increased. Based on that concept, the radius, how much we evaluated, and it lies in our first octant. That is 90 degree. So when it 90 degree, the third dimension also 90. So completely the limits are changed, and we evaluated the result pi square by 8. Next, we moved to another problem, that is evaluate tetrahedron. That is the geometrical figure, the face which is in triangular shape. The function which is given x squared y z dx dy dz. This is the bounded region which is given in our question. So from which put together the 3 dimension, the equation is x plus y plus z equal to 1. So from this, the geometrical figure, we obtained x-axis, y-axis, z-axis. And x-axis, there is a point P. Y-axis, there is a point Q. And z-axis, there is a point R. To evaluate, we have taken a vertical strip for this. Put together the total 3-dimension common mathematical, that equation is, that is xyz 3-dimensional plane. That equation is x plus y plus z equal to 1. From that equation, because the 3 triple integral from where to where, x-axis from to where, y-axis from to where, z-axis from to where. So the limits first we extracted. For the z purpose, this equation help we have taken. When we are concentrating this surface, what is our vertical strip we have taken? That is starting, it touches our surface. Our surface is nothing but our xy plane. So when it lies in our xy plane, automatically z equal to 0. So x plus y equal to 1, from which we extracted the limit, y limit, finally x limit, and we did the integration. So the final result for this problem, we obtained 1 by 2520. So 2520, which is the result we obtained evaluating this triple integral. Thank you very much to you all.
Like, share and subscribe. Hit the bell icon for more updates.